How can you use prime and composite numbers to write the prime factorization of a number? Think about this question during the lesson. Whole numbers greater than 1 are either prime or composite numbers. A composite number can be written as a product of its prime factors, called its prime factorization. How can you find the prime factorization of 48?
Let's take a look.
12 is a composite number because it has more than 2 factors. 5 is a prime number because the only factors of 5 are 1 and 5. Are all odd numbers prime numbers? Explain. No. For example, 9 is an odd number, but it has more than 2 factors, 3 times 3 and 9 times 1. So it is not prime. One way to find the prime factorization of 48 is to write its factors. It is sometimes helpful to start with the least prime factor. What number is always the least prime factor of any even number?
Select your answer.
2 is the least prime factor of any even number. The prime factorization of 48 is 2 times 2 times 2 times 2 times 3, or 2 to the 4th power times 3. Another way to show the prime factorization of a composite number is with a factor tree. You can use a factor tree to find the prime factorization of 48. Write 48 as the product of 2 factors. Continue the process until all of the factors are prime factors. The prime factorization of 48 is 2 times 2 times 2 times 2 times 3, or 2 to the 4th power times 3. How can you check that the prime factorization is correct? You can multiply all of the prime factors and confirm that the product is 48. Now you know how to use prime and composite numbers to write the prime factorization of a number.
Find the prime factorization of 56. Start with the least prime factor.
All right, so let's do the prime factorization. All right, so prime factorization of 56. Let's start with the one on the right here. 2 times what is equal to 56? That's what they're starting us with. So 2 times 28 is equal to 56, and then you break down 28. So you break it down to the prime number. So one number that is prime for 28 is 7 and 4. So then you break down the 4, and that's 2 and 2, and then 7 is prime, so you just write 7. And so we have that as our prime factorization. And then we have the prime factorization of 56 this way. It'll be 2, 2, 2, 7, or 2 to the power of 3, because there's 3 2's, and times 7. And then that is it.
Keisha is putting together bags of supplies. She puts an equal number of craft sticks and an equal number of glue bottles in each bag. There are no supplies left over. What is the greatest number of bags of supplies that Keisha can make?
So let's identify the greatest common factor of 12 and 42. The GCF is the greatest number that is a factor of 2 or more numbers. Click each item below to see the prime factorization and common factors. So 12, we have 2 times 2 times 3. And then for 42, we have 2 times 3 and 7. So they circled the ones that they have in common. So they have 2 and the 3 in common. And so we multiply those common factors together. 2 times 3 is 6. And the greatest common factor of 12 and 42 is 6. Keisha can make 6 bags of supplies. Now let's look at this question.
Keisha has 24 beads to add equally to each bag. Can she still make 6 bags and have no supplies left over? Explain.
The greatest common factor was 6 from the example. So they want to know if she can still have those 6 bags with no beads left over if she has the 24 beads. So you list factors of 24. We have 1 and 24. You have 2 and 12. You have 3 and 8. You have 4 and 6. I believe that's it. And then you circle the ones that are in common with the example. In the example, the factors they had in common definitely were 2, 3, and 6. Those were some common factors that 12 and 42 had from the example, and the greatest of those is 6. So because 6 is also a factor and it's the greatest common factor, yes, she can still make 6 bags and have no supplies left over.
Use the GCF in the distributive property to find the sum of 18 and 24.
Step 1, find the GCF of 18 and 24. So they have listed some prime factors of 18 and 24. And the greatest number that is a factor of both 18 and 24 is 2 and 3. And that gives you the GCF of 6. Step 2, write each number as a product using the GCF as a factor and apply the distributive property. So to rewrite 18 plus 24, we use our GCF of 6, and you make it on the outside of the parentheses, and then you think to yourself, 6 times what equals 18? That's 3. 6 times what equals 24? That'll be 4, and then you put an addition sign in between. And then you solve it by doing parentheses first. 4 plus 3 is 7, and then you multiply 6 and 7, so the answer is 42 if you were to solve that. So the sum of 18 and 24 is 42. Now let's look at this question.
Use the GCF and the distributive property to find the sum of 12 and 36.
So I want to take the time to show you a different way to find the GCF, just so there is another option. So you can do the factors of each of the numbers. So factors of 12 would be 1 and 12, 2 and 6, 3 and 4. Factors of 36 would be 1 and 36, 2 and 18, 3 and 12, 4 and 9, and that's it. Now you circle any of the ones they have in common. So we have 1, we got 12, we got 2, we have 3, we have 4, and oh, I left out a factor for 36. 6 times 6 is 36. and then 6 becomes a factor, common factor. So out of the ones that we circled that they both have in common, which one is the greatest? So the greatest of them all would be 12. They both have 12, and that's the greatest of them. So our GCF, or greatest common factor, is 12. Okay, so now it's asking us to use the GCF and the distributive property to find the sum of 12 plus 36. So we are just going to rewrite that using the GCF. So we're going to put our, I'm going to write this over here just so I have a little bit more space. 12 plus 36. And so we take the GCF, which is 12, and then put parentheses, leave some space, and put a plus sign. So you now have blank space plus a blank space. So let's think. 12 times what equals 12? That answer would be 1. 12 times what equals 36? That would be 3. So now we have just rewritten 12 plus 36 using the GCF and distributive property. Now we have to solve it because they want to know the sum. So now you do 12 times 1 is 12. 12 times 3 is 36. I'm sorry, let me back up. Well, actually, I'll leave that there because that shows you distributive property. But let me use a different color to show you order of operations. I'll use blue. 12, and then 1 plus 3 is 4, and then 12 times 4 is 48. And so that's how you find the sum using the GCF and the distributive property. Use the GCF to simplify the fraction 48 over 60. Step 1. Find the GCF of 48 and 60. So they use their method of finding the prime factorizations. Then the GCF of both is 12. Use the GCF to simplify the fraction. You have 48 over 60 is equal to 48 over 60 divided by that greatest common factor to simplify the fraction, and we get 4 over 5. Simplify each fraction. So let's look at A, and we have 55 over 77. That's the only one I'm going to do. And so we're going to look for the greatest common factor of each. Just off the top of my head, I know that 55 and 77 look like 11 could be the GCF, or at least a factor. So we're going to divide both by 11. 55 divided by 11 is 5. 77 divided by 11 is 7. And then we have simplified that fraction. And you would apply the same for B and C, which I want you to work on your own.
Pedro is making picnic lunches. He wants to buy as many juice bottles as applesauce cups, but no more than he needs to have an equal number of each. How many packages of each should Pedro buy?
The least common multiple, or LCM, is the least common to both numbers. So we have 6 and 8, and they want us to write the prime factorization of each number. So we have 2 times 3, then 2 times 2 times 2. And so the greatest number of times each factor appears in either prime factorization. You multiply these factors, and then it equals 24. So the LCM of 6 and 8 is 24. So Pedro should buy 4 packages of juice and 3 packages of applesauce.
Pedro also buys bottled water and juice pouches for the picnic. There are 12 bottles of water in each case and 10 juice pouches in each box. Pedro wants to buy as few cases and boxes as possible, but still have as many bottles of water as juice pouches. How many of each should he buy? Explain.
We're going to list the multiples of 12 and 10. So we have 12, 24, 36, 48, 60. And then for 10, we have 10, 20, 30, 40, 50, 60. And we're going to circle the ones they have in common. And the only one they have in common is 60. And the least common multiple is the least. So the least common multiple for these two numbers would be 60. So how many should he buy of each? So he should buy 60 of each. So that would mean out of the 12 bottles of water, so water he would need 5 cases, and for the juice he would need to buy 6 cases so that he has 60 of each.